15 mysterious galaxies are shaking the very foundations of modern science. How could they possibly exist before the Big Bang? Scientists are scrambling to explain new observations that suggest our long-standing model of the cosmos may be fundamentally flawed. According to current theories, the galaxies detected by the James Webb Space Telescope shouldn't exist at all, not at that early stage of the universe. Yet they do. They are real, unmistakable, and they're forcing us to rethink everything we thought we knew about the birth and evolution of the universe. Astrophysicist John Mather put it plainly, if galaxies in the universe were so large and developed so early on, then perhaps we need to rethink how quickly matter was able to form, and whether we've understood the beginning of the universe correctly at all. These 15 galaxies, discovered deep in space by the James Webb Telescope, appear far too massive, too mature, and too ancient to fit within the old framework of gradual cosmic evolution. We may be standing at the edge of a revolutionary shift in our understanding of the universe. Some of these galaxies host billions of stars, exhibit surprisingly compact structures, and even show evidence of black holes, all of which seems impossible just a few 100 million years after the Big Bang. This raises a profound question: how could such galaxies have formed so early in the universe's history? According to the standard cosmological model, gas clouds shouldn't have condensed enough to form stars and galaxies on such a large scale until much later. But what we're observing out in space doesn't seem to match our current scientific formulas. Some scientists are calling for a major re-evaluation of cosmology. Others propose the involvement of unknown physical processes that could explain far more than just the presence of these 15 seemingly impossible galaxies. There are even researchers who suggest we might be seeing remnants of an earlier universe. Is it possible that the universe moves through cycles of renewal? Or that the early cosmos was far different than we've imagined? Perhaps the James Webb Space Telescope hasn't just discovered distant galaxies, maybe it has opened a window into an entirely new cosmic reality. We may be on the verge of unlocking entirely new dimensions of understanding, realms where time, space, and even origin no longer define the limits of reality. These 15 mysterious galaxies might be pointing us toward ideas we've never previously considered. The universe could be far more profound, enigmatic, and awe-inspiring than we ever imagined, and we're only just beginning to uncover its secrets. What do we truly know? Strangely enough, the deeper we explore, the more it seems our understanding is just a flicker of light in an immense sea of unknowns. Modern science has achieved incredible things. We've split atoms, peered into distant galaxies, unraveled the code of life, and created intelligent machines. Our equations work, our technology functions, but instead of offering final answers, they often lead us to even more questions. Much of what we call knowledge is built on models, representations of reality, not necessarily the reality itself. It's entirely possible that our current scientific framework is only scratching the surface of something much deeper. Take gravity, for instance. It's one of the best described forces in physics, yet we still don't fully understand what it actually is. In fact, some theories suggest gravity might not exist in the way we think it does, offering evidence just as compelling as the models we rely on. Then there's dark matter and dark energy, which together make up about 95% of the universe. We've never directly observed either, and they remain scientifically unproven. While our standard models in cosmology and particle physics have brought us far, they may only be part of a much larger, more intricate puzzle. Yet, science consistently falls short when it comes to the margins. It struggles to fully account for the Big Bang in all its complexity, to explain singularities, the interiors of black holes, or the nature of consciousness. We need to remain grounded. Science is still an evolving, uncertain method of understanding the world. It's not a collection of absolute truths. In many ways, science represents a continual pursuit of knowledge, defined more by curiosity and questioning than by certainty, especially when exploring the universe, which we can observe but not directly reach or measure. Our tools are limited. The James Webb Space Telescope stands as one of humanity's greatest technological achievements, yet even this remarkable instrument has its boundaries. It can observe and analyze, but it cannot explain or connect all the dots we urgently seek to understand. Even in this era of rapid technological advancement, uncertainty, inquiry, and the need for ongoing self-correction persist. When the James Webb Space Telescope uncovers galaxies that defy current scientific expectations, it's not a setback, it's a step forward. Such discoveries push science to re-evaluate itself, and that process is the essence of progress. The JWST's mission to explore the edge of the universe was designed to tackle some of astronomy's most profound questions. How did the first stars and galaxies form? Are there potentially habitable exoplanets? How do planetary systems come into being? Equipped with a massive 6.5-meter primary mirror and cutting-edge instruments, Webb can detect light that has traveled over 13.5 billion light-years. Alongside its giant mirror, the telescope carries an array of advanced tools that allow it to observe the universe's oldest and most distant objects with unmatched precision. One of its key instruments, the near-infrared camera, NIRCam, captures faint infrared light from far-off galaxies, stars, and exoplanets, light that other telescopes simply can't detect. The near-infrared spectrograph, NIRSpec, analyzes the chemical makeup and temperature of celestial objects by studying their light patterns. Remarkably, it can observe up to 100 targets at once, something no other instrument has achieved so far. Meanwhile, MIRI, the mid-infrared instrument, affectionately nicknamed by astronomy fans, is a standout in its own right. It detects light in the mid-infrared spectrum, allowing it to capture exceptionally cold objects like dust clouds and low-temperature exoplanets. This capability enables us to explore cosmic structures previously hidden from view. Positioned about 1.5 million kilometers from Earth at Lagrange Point 2, the James Webb Space Telescope, JWST, operates in a stable, undisturbed environment. This gives it the ability to deliver images with unprecedented clarity and depth. With its extraordinary sensitivity and cutting-edge instruments, JWST can detect the earliest galaxies, investigate exoplanets for potential signs of life, and unravel the mysteries of the universe's formative epochs. The JWST marks a major milestone in space exploration and promises even more revolutionary insights in the years ahead. The so-called Dark Ages of the universe remain one of the most mysterious and intriguing periods in cosmology. This era occurred shortly after the Big Bang, before the first stars ignited and galaxies took shape. During this time, the universe was shrouded in darkness, filled with neutral hydrogen gas that emitted no visible light. Understanding this epoch is crucial for uncovering the full story of how light and structure emerged in the cosmos. At least, that's how researchers understood it, until now. This period of darkness poses a major challenge, as it's crucial to cosmology yet incredibly difficult to study. Why? The reason is fairly straightforward. No light sources existed during the so-called Dark Age, which means there are almost no direct ways to observe it. Astronomers have had to rely on indirect methods, like analyzing the cosmic microwave background or using theoretical models. The Dark Age is believed to have ended with a phase called reionization, when the first stars ionized the surrounding gas, making the universe visible for the first time. The James Webb Space Telescope was expected to capture the era when these first stars began to form. But surprisingly, its images don't show young galaxies or stellar nurseries. Instead, we're seeing galaxies that appear fully formed and highly evolved, by the thousands. We can only be certain if there was truly no light before the first stars by confirming complete darkness in that era. But what if that darkness never appears? In that case, our current cosmological models could be fundamentally flawed. Scientists are now developing advanced radio telescopes capable of detecting signals from neutral hydrogen during that ancient time. One such effort is the Square Kilometre Array, which is expected to shed light on the universe's so-called Dark Age. Studying this epoch could not only reveal how the first cosmic structures formed but also answer deep questions about the universe's origin and evolution.